Okay, recording in progress. So this is the first session of a total of 5 sessions where we will talk about low resource natural language processing, specifically with a lot of interest on multilinguality and machine translation. This is part of a project called LT-Bridge, that's bridging technologies, language technologies between different languages and countries. And the project has a consortium where we have the University of Malta here, and also the ADAPT Center and DCU in Dublin, and the FKI in Germany. And I'm part of the group in Germany in the FKI. So this is the main framework of the conferences, and I will be talking for these 5 sessions, so maybe I should say some words on who I am. So I'm Cristina España, and as I said, I'm in the FKI group. I'm the team lead for the machine translation group in the Multilinguality Lab, directed by Joseph Van Genabit. So I've been working on language technologies and machine translation for more than 10 years now, but even my first experiences in science were on physics and cosmology, so a bit different, but now I have quite an expertise on machine translation. So I hope I can explain you some things related to language technologies that are of your interest. So how is it going to be all this organized? So as I've said, and as you already know, because you have registered, we will have 5 sessions. Each sessions will be 90 minutes. The general topic is going to be low resource natural language processing, but with the main focus machine translation. And what we will see is the path towards low resource machine translation. And we will see that some of the things that we use in machine translation are in fact general to all NLP tasks, or a lot of NLP tasks. So this is why the title is more general. We will explore different technologies with different architectures that we use in machine translation, but also in question answering, in language modeling, in several tasks. Also, a product of this project is the organization of a shared task. And the shared task is on multilingual translation. And when you use multilinguality, sometimes it's because you are in a low resource setting. So you have lots of languages. For some languages, you have more resources. For some languages, you have less. And you use multilinguality as a tool for low resource settings. I'm saying this because this series of webinars is going to be very descriptive and going into details in some cases, but not always. So for some of you who already have a lot of experience, I would ask you or suggest you to participate in this shared task, because in the last session, I'll try to wrap up and comment on the technologies that people is using for this shared task, and also for the remaining shared tasks or WNT. So how is people approaching low resource machine translation in real life? And which are the architectures that perform best? So if you try to do something and submit there, we will kind of discuss your system or use approaches at the end of these webinars. But you cannot wait till we have some of the webinars done, because the evaluation campaign is coming very soon. So at the end of June, we will deliver the test set. So yeah, this is for people, for those of you who have already experience on machine translation and want to try this multilingual and low resource setting. Okay, what's the general plan of the sessions? So first I will motivate the low resource setting here. What do we mean by that? Why do we need different approaches to work in the low resource setting? And then I will start talking about technologies that we use for that. So the main blocks will be word embeddings, transformer models, and supervised neural machine translation, self-supervised neural machine translation. And as I just said, at the end, we will kind of explore the state of the art on the topic for machine translation. But as I also said, this is going to be general. let me expand the topics we will cover in word embeddings and transformer model. And you see that this is really quite general for all NLP tasks. We were talking about the basics of word embeddings, monolingual embeddings, and cross-lingual embeddings. Cross-lingual embeddings are fundamental for unsupervised neural machine translation, for instance, but are its own and have their own research area, which is very active, by the way. And also we will be introducing transformer models, see how they perform language modeling, but also machine translation, how we can extract contextual embedding from them, and how it's introduced, how the network works, and we will see how quite a few details about it. Again, this is general, this can be used for NLP in general, but we will focus on the topics that will help us to understand later self-supervised and unsupervised neural machine translation. So today, what are we going to do today? So I will spend half of the time or maybe a bit more, because I'm usually slow talking, I realize, talking about the motivation and thoughts on low resource natural language processing. And in the second part, we will explain the very, very basics or word embeddings, because word embeddings are the basic unit in natural language processing today. So I don't want to go into the questions by the sense, I'm not going to speak today about cost functions or minimizations or whatever. I want to understand the concepts and see what's happening there. I will cover some monolingual embeddings. I will talk about prediction-based embeddings and frequency-based embeddings. And I will leave everything ready to talk about cross-lingual embeddings in the next session, because this is really the key point that we are going to use for neural machine translation. But before I start with all of this, we will having more than 7 hours during this session. So I'd like to know a bit about your background, about what have you been doing. Also, because today the session is going to be very introductory, but I would like to go a bit deeper into the details in the next session. So if I know the background of the people who is joining us, I will be able to do something that doesn't allow you to sleep, at least during these sessions, okay? So in these seminars, unfortunately, everything is online, so it's difficult to see your faces and how you react to my comments to see if you understand things. So what I will try to do is, from time to time, I will ask questions in an interactive way. We will use direct poll. So while I can have some feedback from you to see if you understand things, if I'm going too fast, or if you want to suggest something. Let's try if it's working now. So if you go to this link that you have here, or scan this QR code here, you should go to a web page. And now is when I need to share another screen and not this one, so that we can see what's happening there. Let me see if I can do it properly. Okay, so now you should be seeing my browser. If it's not the case, anyone can unmute itself and just complain, please. I assume that you can go to this web page or scan the code. And once you are there, you should be seeing a question like this. This is just to check, oh, great, you are voting, so this means that it's working. I'm just going to wait like 5 seconds, 10 seconds, so that everyone can check this works. Okay, I'm happy to see that it's not raining everywhere. Okay, just waiting for some seconds more. We have more or less half of the people voting. Okay, so let's start with the questions that are not relating to the pitch. Oh, still some people voting. Okay, so let's start with the first question. As I say, this is only to know what are you working on and to which detail do you expect me to explain things, or what can I explain. So please, if you can say what is your main background, do you work on machine translation, deep learning in general? Do you have experience on natural language processing, computer science, linguistics, or nothing related, but you are just interested in these webinars? Okay, so things stop moving. I have a couple of more questions. So what kind of things do you already know? Do you know about word embeddings, transformer models, contextual embeddings, sequence-to-sequence architectures in general, multilingual natural language processing, machine translation? Oh, that's great. All of you already know about everything. So okay, lot of knowledge on word embeddings. Good. And finally, the last question here. What do you want to achieve with these webinars? What would you like to know after these 5 sections? So you expect to get a general knowledge on machine translation here, a general knowledge on natural language in general for the low resource settings. Do you want to be able to use neural machine translation in a real settings? Just to get the intuitions on how to do machine translation in the low resource settings, if it's different to standard machine translation, or you are planning to participate in the shared task. So do you want to know a bit more in general? Okay, so I assume that most of you already know about machine translation in general, so you want to participate in this low resource setting. Okay, let me go back to the slides now. And that means sharing the screen. Okay, so yeah, we are back. You have already answered all these things. And we can start with the talk, with today's talk. So yeah, let me start with the motivation part, where I will talk a bit about language diversity, low resource settings, and NLP techniques for these low resource settings. Good. So as some of you might already know, we have more than 7,000 languages in the world. Even if there is no clear definition of a language, of what a language is, sometimes there is a mixture between dialects, languages, and so the distinction is not that clear. The countings say that we have around 7,000. These 7,000 languages are divided in families. There are like 141 families, and 6 of them account for 2/3 of all the languages in the world. And 5 over 6% of the world population is covered by six of these languages. So this is already a first indication that even if for a speaker, its own language is the most important language in the world, and all of them are at the same level, at the end, when you look all the languages in the world, all the languages that we have, not all of them have the same representation in the world. These statistics are really very interesting. You can see how languages group together and which are their roots. So if you are interested, I have put here 3 interesting links when you can learn a bit more about this. The ethnologue, glottolog, and linguistic maps. You can see how languages are distributed according to the family linguistic categories. And this is something that I'm saying very general here, but a few slides later, I will comment that a low resource setting might depend on the structure of the language. So if you need to understand if that language is, let's say, difficult or easy for a task, it's a good way to go. So you visit these pages and you learn a bit about the linguistic characteristics of your language. Also, Wikipedia, of course, can help in a more straightforward way on that. I'd like to talk a bit on some related concepts. I will talk more about language diversity, what happens with these 7,000 languages that we have in our world. Is this related to the population density? Would we have more people, we have more languages? And what's happening with all these languages? What's the concept of endangered languages? Are all the languages equally healthy? And what's the meaning of digital richness? So a language is needing digital resources nowadays to survive. What's happening? And what can we say for a language to be a low resource language? And this seems to be the main topic of our webinars here. But also in a few slides, I will argue that we are not really concerned about low resource languages because this is something really very abstract to qualify. We will be interested in knowing about low resource settings or low resource scenarios. This is something we can somehow quantify and try to tackle. We cannot increase the population that talks a language. This is out of the scope of deep learning, at least from now. So from all these 77,000 languages, not all of them are really having the same status. And this is something that is monitored. I'm sorry, I'm going too fast. This is something that is being monitored by several associations, let's say. The UNESCO, for instance, define the health of the languages that we have in our world in using this scale. This definition was done in 2010, so that they kind of divided the languages according to the health, the vitality in the community they are spoken. So the first group is the group of safe languages. Safe languages means that the language is not endangered at all. So it's going to be living for the first years without any problem. And that means the definition they give is that a language can survive easily if there is transmission of the language from one generation from another one. So a language is safe if the language is spoken by sons, fathers, and grandparents. So if everyone is communicating with this language, the language will survive. And then going from this to every time a lower level, we have a different scale for dividing the language, according if they are vulnerable, endangered, severely endangered, critically endangered, or already extinct. So vulnerable languages are those that are spoken by everyone, but not always. So you speak your language, but depending on the situation, you speak another one. And this another one is very important. The language starts to be endangered when children are not learning this language at home as the mother language. It's severely endangered when the language is only spoken by the grandparents. So this is what happens when, after some years of a language being qualified as endangered. And finally, we have the critically endangered languages, but only the grandparents are able to speak this language, and they don't speak it a lot. So yeah, the children are not going to continue this language anymore. Of at least this is the prediction. And there are also quite several languages that are already extinct. So yeah, we knew that were spoken before, but they are no longer active in the world. And how does this divide the languages, the 7,000 that we have seen before? So yeah, no need to look at all the numbers now, but if you look at the right bottom corner, you see that we have 3,000 languages that are in a status that is not safe. So across the countries, almost half all the languages have some kind of degree of being endangered. So yeah, you have this link below that you can see all these statistics and the nice table. And also you go to the UNESCO webpage, you will have a report talking about this and about the problems that all these languages have now and how to try to improve their health, let's say. Are all these languages equally distributing of the world? How much diverse is the world, and where are the languages in more danger of being extinct? So this is something you can see in this plot. And in this plot, what you can see is that there is more or less a spread of an endangered language everywhere in the world, but we can see like 3 hotspots here. I would say that one is Central America and the north of South America. We have another spot of endangered languages in the sub-Saharan Africa here. And then we have another spot here in the east of Asia and Oceania. So another spot here. So the situation regarding endangered language is really very difficult on the world. We have these 3 hotspots with a lot of languages in danger. And what the cause or the correlation with these hotspots with the density of population is not really straightforward. So we cannot say what's going on there to try to help these languages. It's just a combination of factors. So if, let me put as an example, I overplot on the previous image the density of population in the world. We go to the east part of the world and see, for instance, that India and the southeast of China have really a lot of population. But if you remember from before, this was the previous image. Even if India, there is a lot of population, there are less languages in danger than in South China, for instance. Yeah, let me plot. So, and that's an example of to say that there is no single reason for a language to be in danger of extinction. What could be that it has a low population, so we are in a place where with very few speakers, so when the speakers disappears, of course the language disappears, it doesn't have any utility anymore. Another reason can be the coexistence with a strong language, so in the same region 2 more languages coexist. One is a very strong language which everyone can communicate with a larger community. So this is the one that's being adopted by the population. Another reason might be politics, just a reason to make minorities even more minor in a country. So and a way to go is just try to delete their language. And a characteristics that I think it's taking every day more importance is lagging behind in digital content. So there are a lot of languages which have no presence at all in internet or in digital components right now. And this is in a world where a lot of communication is done via internet, not being present there like makes it more difficult to survive. It's like very similar to the coexistence with a strong language. In this case, the strong language in internet would be Chinese and English, for instance, which is more in the internet is on these 2 languages. So we can say that those languages that are in high level of being in danger of extinction are low resource languages. Of course, if there are no speakers, there are no resources. Usually the opposite is not always true. You can have lots of low resource languages that are not in danger of extinction, at least yet. And as what happened with the danger of extinction, there is no single cause for being low resource. It's low resource language. It's also a combination of several factors. So what could we mean by a low resource language? There is no a universal definition for a language to be a low resource. We can be meaning lots of things. What's the meaning of that? We have few linguistic resources. We have few digital resources so that we can do natural language processing with them. We have few data. What's the exact meaning? Sorry, so yeah, I'm not going to say the meaning because I really don't know how we could define properly low resource language, but let me give you some examples of several languages with respect to the task we can perform on them. This plot is taken from a survey on low resource NLP done by Frederick et al. last year. It's quite interesting. And then you can see all the tasks and resources that we can approach for several languages. Let's say that English is one of the big languages. English would be spoken by 1,000 million speakers here. And we have really lots of resources. We have lots of resources and we can work, I think it's around 19 tasks, different natural language processing tasks for English. Another example here, we have Yoruba. Yoruba is spoken by quite a significant less amount of people, but still a lot of people. 40 million people in Africa speak Yoruba. And in that case, there are very active creating resources for natural language processing, and we can perform 13 NLP tasks here. Let me go to the other side of the plot here. We have Nahuatl. Nahuatl is a language spoken in Central America. It's spoken by almost 2 million people, so many less than English and Yoruba. And we can see that we have, they cover only six of the natural language processing tasks. Still, 6 tasks is really a lot of tasks. There are lots of languages that would love to have this number of resources for natural language processing. But an interesting thing here is when we compare Nahuatl to Estonian. Estonian is a language in Europe that is spoken by less people, only 1 million, well, 1.3 million people speak Estonian. And it seems to be quite an active community and with a lot of resources and quite a digitally rich language. Because with a few more than 1 million speakers, for Estonian, we have like 15 supported tasks. So that's more tasks that Yoruba has with 40 million speakers. So the definition of low resource is not really standard. Different amount of speakers, different amount of tasks, different amount of data. So different factors apply here. So, and this is one of the reasons that in these webinars, I'm not going to be talking a lot about a low resource language, but I will talking a lot about low resource settings. And this is because being low resource will depend on different things. Let me just list some of them here. Being low resource depends on the task. It's not the same being low resource for speech recognition, machine translation of part of speech tagging, for instance. We can have a language with a lot of resources for speech because we have a community when we have recorded lots of voice, we have several videos, but we don't have written text. So if we don't have written text, it's difficult that we could do machine translation, but we can do probably very well speech recognition because we have all these speech things. So in this case, it will be dependent on the task. Also, I've added here part of speech tagging because this is a different kind of task when we need resources that are annotated with labels. And this is something that you cannot go just put a mic in front of the people to get speeches there. This is something that you need to spend some some time creating manually the resources here at a different level in this case. Also, low resource can be related to the language. So, and the language complexity. This is what I was talking at the beginning when I told you that in some cases it's very good to know the characteristics of the language. For instance, I'm listing here the comparison between English and Hungarian. If you want to study morphology of a language, probably I will need much less data to study what's happening in English than in Hungarian when you have really rich morphology and declination. So also the amount of data that you need, the fact that it's a low resource setting or a high resource setting might depend on the complexity of your language. Another thing that is sometimes forgotten is that low resource setting can be also a changing domain. So let me give you this example here. Imagine we are working in English and we want to generate text. This is a very well-performed task nowadays because we have a huge amount of monolingual English data. But this is an example that we faced some months ago. Imagine what you want to do is a machine translation for English into German, for instance. This is a quite successful task. We have a lot of parallel sentence. So if we train a system, we will get high quality. But in March last year, people started to want to get translation on Corona and information on COVID, what was happening. And this was a new situation. We didn't have data on that. So we need to adapt all our systems to this new domain, in able to be able to perform well on this task. So under this point of view, translation even into English was a low resource setting last year, simply because we didn't have data on this domain. And also, last point here, the definition of low resource setting of low resource language depends on the author. So depending on your work, you say that a low resource setting is something at one threshold, or you put more data needed, or even you get a high quality and high resource language pair or language, and you diminish the amount of data that you have to simulate a low resource setting. So this is quite a subjective thing to do. So in the rest of these seminars, what I will be talking about is on my own definition, because this is something that will be quite useful to put examples. So a low resource setting or a low resource scenario will be a place where I cannot apply the standard NLP techniques because they give really very bad performance. The translation quality, the text generation quality, whatever task we are performing will be very bad. And of course, this is not a definition in general that you can use. This is something, the definition that we will use from here on in order to define the work that we are doing here. Okay. So what's your intuition about this? So yeah, I've talked a lot, and this is all everything very abstract, but yeah, where will you put this threshold on low resource system? Let's assume that now we want to do machine translation. I can tell you neural machine translation, for instance, and I give you a language pair where we have 125,000 parallel sentences. What would you say? This is a low resources scenario, high resources scenario, mid resources scenario? You cannot answer with the info that I'm giving, or you really don't know because you are not an expert on machine translation.
On the vote screen.
Sorry, let me share the other screen now. Okay. Can you, yes, I see that you can already vote. Okay, triple tie here. Okay, I will answer this with an example. I see that for all of you it's clear that this is not a high resource scenario. Just to confirm this, I can tell you that the best system, for instance, for French English now are using like 40 million parallel sentences, and yeah, for German English, some systems also use like 40 millions of parallel sentences. So yeah, 125K seems to be well below. So yeah, and there is kind of a lot of people saying it's low resource, and some of you saying it's mid resource, and some of them say that you cannot answer. So my preferred answer here would be I cannot answer with this information, but the rest are not really wrong. So let me justify this. And this is related to the things that we have been talking before. And now I go back to sharing the other stuff. This is the lowest part of the presentation sharing. Okay, so yeah, we are here. And as I told you, let me answer with an example. So yeah, just a few weeks ago, we had the results from a shared task on machine translation. This was a shared task to translate between indigenous languages of the Americas. So these are languages that are mostly spoken in one of the hotspots that we have seen before in Central America and the north of South America. And there are not really lots of resources for these languages. So what the people of the organization did is they selected some of the languages for those who had at least some resources. They collected a training set with this, and then they manually created development and test sets. So, and this is the numbers that they go here. So yeah, before I asked about 125,000 sentences, because Quechua was the language where they were able to get more parallel sentences, and they got these languages. But then you can see that in the different languages that they consider, some of them had less than 4,000 for training, like Ashakaninka, sorry, I don't know how to pronounce this. And around 20,000 Guarani Nahuatl, we have seen Nahuatl before. And I don't know, for Wixárika, we had like 9,000 parallel sentences. This is quite below 125. So what do we do here? Is this a low resource setting? Is this a medium resource setting? What are we talking about? It's clear that it is not high resource machine translation. So to check this, I'm sharing the results that one of the participants put in their paper, and I'm sharing this one because they have the baseline here. This is what I have said before. My definition of low resource language will be a language pair for which our standard tools don't perform well or don't perform a lot. So here is the quality of the translation systems that they got. The baseline system is a standard system that you would use for neural machine translation, a transformer architecture, set of sequence to sequence, and let's see what you have. And translation quality here is measured in terms of Bleu scores. We will talk about Bleu scores later in the course, but for now, the only thing that we need to know is that it's a translation accuracy measure. It counts more or less the number of n-grams that are correct in your translation and what should be the correct translation. And if you look at the baseline, you'll see the translation quality for all the language pairs is very close to 0. And the best one is this, which I think is Wixárika, this one. The top performance is translation quality of 2. I would say that translation quality is good if it's around 40, Bleu score of 40. You can understand things more or less well with Bleu score of 15 or 20. course, there is no a good number to say this, a clear threshold, but more or less you can understand things already there. So when we see Bleu scores of 0, 1, 2, we are not really learning nothing at all. A Bleu score of 2 might mean that you are matching correctly punctuation. So yeah, you are not getting any meaning at all. So this is really the definition of a low resource scenario in this task. It can be for whatever reason it is, because the language is very complex, because the test set has a domain that is really very different from your training set, because you don't have enough data. The reason can be very different, but the final conclusion is that all of these are low resource, it's a low resource setting. And it's the same for the language as, let me check, it was, yeah, with Sarika, with now 100 sentences that has a Bleu score of 2, and Nahuatl with 125,000 sentences, which has even a lower Bleu score, in 0. So in this competition, what the people is design systems to deal better with the problem, to be able to translate. And we see here the results of a couple or 3 systems. Here, Helsinki was the best performing systems, and we see that the Bleu scores that it got were in average about 5. There were 2 good cases with Bleu score of 15 and 10. But I think that they were using additional data here, so not really a good estimation of the training set. So what was my conclusion here? My conclusion here is that a low resource setting can be because of a lot of different reasons. And there are lots of cases that can be approached with low resource technologies. Even if you had 100,000 sentences or you have just 1,000 sentences. How do we approach this problem of low resource settings? There are lots of things to do, lots of technologies, and again, there is no universal answer. So there is not a methodology that works the best always, and it's clear that you have to use that. The thing that I'm doing here is just listing some of the keywords that we will try to understand during these days. You can also Google for them to find a lot of information, but this is the kind of topics that one can address in order to work with in low resource settings. So one of very known and explored technique is transfer learning. We also will learn about few-shot learning, pre-training models, how can they help, multitask learning, data augmentation techniques, semi-supervised training, zero-shot learning, weak supervision, distillation, and domain adaptation. This is just an example of keywords that we will try to describe later and we will use. And I'm ending with this domain adaptation because it's a relation that I like a lot, is that in this world of deep learning techniques, when you use neural networks and general technologies, at the end, domain adaptation and a new language, so changing the domain or changing the language is exactly the same problem. So you can apply the same solutions to improve your system in a new domain, and the same technologies you could apply also to improve your system in a new language. And this is something that I find really, really interesting. We can divide all these technologies in 4 groups. These 4 groups are something interrelated. So this is just a distinction that I'm making here to try to have general ideas, but of course, more than one technique can be done together. So the first group would be the techniques that deal with data. So what can we do? We can do data collection or data augmentation. There are techniques that are related to machine translation itself. We can do supervised learning instead of supervised if we don't have labels. We can do weak supervision if we have few labels. We can do transfer learning. Another general characteristic that can help in improving a low resource setting is using multilinguality or multimodality. So even if you are only interested in a language and in a task, you can use the help of other languages or of other modalities for improving your own tasks. For other modalities, I mean, if you want to work with speech, maybe using also text or images can help, and all the combinations you can think on this. And then another group of models that will help you to work in the low resource setting is simply forget about the standard NLP system that works for everything and design a specific architecture for your problem. Of course, this is very time consuming and it's a bit different to the previous one, but it could be one way to go also. So for instance, for data techniques, we have data collection, which is the first thing one would do if one has the resources. Okay, one of my problems is I don't have enough data to train a system, then I try to get more data. This is something not difficult, but sometimes it's also impossible. So you cannot get more data on this task. So a good alternative, if you cannot get real data, is try to do data augmentation in a systematic way. This is something that is not good only for low resource languages. In some cases, it's not always good for low resource languages, but it's always good in general. Even when you have lots of data, adding additional data that has been done synthetically as and is not real high quality one can help you to improve your performance, because you are kind of regularizing your network and this helps. Some methods that we have for data augmentation. So you can just do oversampling. This is very useful when you have data that is mixed in several domains or in several languages. So, and they are not balanced in quantity. So you have lots of more data in one of the categories than in the other ones. So the most simple thing to do is just doing oversampling or undersampling in the case needed. You can just transform existing sentences or existing instances of whatever your task is, or create new ones. This is more general, so let me give some examples. In machine translation, this data augmentation would mean that you add noise to sentences that you already have. You can add noise by changing one of the words that you have with a different word. You can do back translation, for instance. Back translation means that you don't have parallel data, but you have monolingual data. So you take this data and translate it with a previous machine translation system. This is not your best system, but it's something that you can build with your reduced data. So you translate some of your monolingual data, and this way you have more additional data to retrain your system now with more instances. If you were working in vision, you wouldn't need to worry about text, but then you will need to worry about getting more images. Getting more images seems to be a bit easier, and it has been done very successfully a lot of times. And in that case, it means that you can just changing them. You have an image, you can change the geometry, and that can mean just inverting, rotating, translating your image. You can change the color, and this is not going to, probably this is not going to change the label that you have for that image. An example I can give you in speech. For instance, in speech, now we are not worried about images or text, we are more worried about sounds. So what we are working here is with waves. So you can change the sample rate of a wave, you can go directly to the spectrogram and do some cut and paste, that is just remove a part of your spectrogram there, or add, duplicate one part, or you can do several things. And all these techniques that seems that you are only using, adding more noise to your data, really have been proving to be very successful in all the tasks that have been applied. So data augmentation is always a good way to go when you don't have enough data to perform a task. Let's see some comments on the techniques that are related to machine learning. Let me summarize a couple here. We can talk about weak supervision or transfer learning. In fact, both of them are very much related. And they are also related to data augmentation because, as I've said before, there is no straight line separating all the technologies. So what's going to do weak supervision? With weak supervision, we are going to use noisy instances as signals to label large amount of training data. So you don't really have lots of data here, and you have some data that has not a very good quality, but it's all that you have, right? So yeah, let's use it. So let's use this information to create more data annotated with this. And once you have more data, you go to a standard supervised setting. This is useful for name entity recognition of part of speech tagging, when you can, for instance, annotate but have a few number of sentences, train a system there, and then use it to annotate more sentences. But this is also exactly the example that I was telling you before with back translation. Okay, so yeah, you have few data, so you train a neural machine translation system or a machine translation in general. With this, you translate more data and you retrain again, in a supervised setting with the new data that you have. On the other hand, you have transfer learning. Transfer learning is really very important these days because it's being used for many different applications with very good performance. And the main idea here is that you have a pre-trained model that is general and is very good for a task. And now you want to perform a different task. So the idea of transfer learning is that you will initialize or start your system with this pre-trained model that might have nothing to do with your task, but is a way to start with. And this is used for domain adaptation or for task adaptation, for instance. So you have a very good machine translation system that translates news. And now your problem is that you're going to translate on sports that, well, it might be different kind of news. So what you do is use this high quality model that it's able to translate news with very good quality, and just take it as a standard point to train a new system with sports news. You can do the same with another task. So, or it's also been used to adapt a model to an unseen language. So you have a model that is very good translating English, German, and French, and you try to adapt it to be able to work also with Dutch. So the techniques that you are using for this are really very similar. And as I've said, transfer learning is quite important these days, used in lots of applications. This classification comes from the PhD thesis from Sebastian Ruder, and you see that different kinds of transfer learning are used for domain adaptation, cross-lingual learning, multitask learning, or sequential transfer learning. I'm not going to describe everything here, but from time to time, I will pointing you to names that are a very good place to start. So for instance, Sebastian Ruder, besides being a great scientist, is great explaining things. So if you want to know a bit more about this topic, and some things we will talk later, I advise you, and I would recommend looking at his PhD thesis and the blogs he has written on this topic. It's really very, very informative and easy to follow. So yeah, let me give a last example to all the things I've been talking in the last slides. We continue with examples related to machine translation. So now our task is we want to do translation between Yoruba and English. So what do we do first? So we go to the sites we know they collect resources for machine translation, or we look a bit for where we can look for corpora. And we see that if we are willing to use high quality corpus, we have mainly the Bible and the Jehovah's Witnesses corpus. These corpus are in a lot of languages. So yeah, we find it also for Yoruba. The problem here, yeah, all of them are religious corpora. So it might be that they perform quite bad for another domain. But the good thing, yeah, we have 500,000 parallel sentences that with this, we could get relatively good translation, we can imagine. Another thing we don't know, or at least I didn't know before starting working in this language pair, is how is Yoruba? Is it really very difficult? How is different from English? Is it going to be an easy or a difficult task? Do we have enough with this 500,000 parallel sentence? On all these questions, do we need to know to answer if we are in a low resource setting or not? And how can we know? So a first thing to do if we want to know if we are in a low resource setting or not, okay, let's apply a standard machine translation system, a transformer architecture that is working nowadays good when we have a lot of data, and see what happens. Again, we are using Bleu score to estimate translation quality here, and we evaluate what's happening when we use this data to train a transformer, and we evaluate on different data. What we see is that if we use only the Bible, that's this 30,000 parallel sentence, we got Bleu scores of around 2. So this is what I was saying before. I'm probably just guessing the punctuation. So if I make a heuristic that just copies the punctuation and the output, I will be probably getting this 1 or 2 Bleu score. When we use the Yoruba-English corpus, this is larger, more than 400,000 sentences. We get a bump in translation quality, closer to 7, 9, and if we combine both of them, a bit more improvement, 8, 10 Bleu score. This is something we can probably guess the topic that we are talking about, so we can guess open impressions, but translation quality is not going to be good enough. So this is a case when we can start thinking of applying low resource techniques to deal with this translation problem. In this case, the translation problem would be Yoruba to English translation and English to Yoruba. We are approaching both directions. And we want to translate data that is not extremely related to the religious domain. How we would approach this? So the first thing we would try to do is to collect or generate more data. This for Yoruba, there is, and several African languages, there is a nice initiative called the Masakane project, where people is trying to collect and generate more data for these African languages. So in this case, they realized about the problem that they had for Yoruba-English, and they decided to collect more data and to generate more data on different domains, so that they have high quality parallel sentence in domains not others than religious domain. The idea here was to get corpora and sentences from different domains, so that one can use domain adaptation techniques to be able to perform better in several tasks. So this is a summary of the sentences that they translated by hand by professional translators and volunteers. So at the end, they developed this menu corpus with 20,000 parallel sentences, high quality, with different domains: news, TED Talks, books, technology, proverbs, and a summary of smaller domains. And there is this standard split between training, development, and test set. The results that I've been showing you before were using this test set. So the translation quality using religious domain was very bad using this test set. And I'm not showing you the results here, but there are subdomains that are better and subdomains that are worse. So this is the first way to go if we can. So let's try to generate more data. And now that you have more data, we can still try to apply low resource technique to improve translation quality. Things that we can do. We can do transfer learning for domain adaptation. So we have our general domain system for the religious, the religious domain system that would be performing relatively well in religious text, but was performing bad in this general domain test set. And we can do part of this test set to try to adapt to the new domains. We can then create a system that is better than the one that we had before, and do some back translation here to get more additional sentences. Now we have more sentences, so we can retrain again using the weak supervision approach. So now we have more sentences that will have some noise, but even with that, we can try to retrain our system and get more data and see what's happening here. Another approach that we can do, and now we have a high quality heterogeneous corpus. So another thing what we could do is take a huge pre-trained model in either other languages or other domains that has nothing to do with our initial task with the religious domain translation, and do transfer learning with our menu corpus. And another thing that we can do is see how multilinguality works in this case. So if we don't have only Yoruba-English, but we consider that we have also in our models, we have trained with languages that are close to Yoruba and are close to English. Maybe this is improving our results. Let's see what's happening. So the first line I'm showing you here is the results that one get with the baseline that I showed you before. So from going from English into Yoruba, we got a low score of 8. Yoruba into English is a bit easier because English is quite a good language to translate into. One always gets good better performance there. So we got below 8 in one direction, below 11 in the other direction. Now we use our menu corpus with transfer learning techniques to do some kind of domain adaptation and see how much we can improve this using 10,000 sentences more. And we see that we are increasing translation quality by 3-4 block points here. So this is already a significant improvement. Not great quality, but we are doing better. Another thing that we could do is use our menu corpus, these 10 case sentences. Remember that the other 10 case are now used for testing and validation, but not for training. So what we can do is put them together with our initial corpus. This is another way to perform domain adaptation. And afterwards, also use it for transfer learning. So more domain adaptation on top of domain adapted system. In this case, we get a bit more of improvement, but it's not really very high as compared to the previous improvement. So we are, at most, we are improving a blue point more. And finally, we can use here also data augmentation techniques. In the case of machine translation, is back translation lots of times. So if we add back translation, we are getting a significant improvement when translated into English. But in this case, when translating into Yoruba, the translation is not that good. This might be again related to the difference between the languages, the difference between English and Yoruba. So with English, translation seems to be a bit easier. So your translation system initial to make back translation would be a bit better. And that makes back translation more efficient here. So yeah, we are going from 8 to 12 and from 10 to 18. So we are doing something good already with this low resource techniques. More things that we can do. We can try to do task adaptation in this case using pre-trained models. We will see these pre-trained models later in the sessions, but I just introduced here this T5 model. T5 model is a system trained by Google that was trained using an incredible amount of sentences that is used for sequence-to-sequence tasks. So this is not just machine translation. This is monolingual. It was trained with several languages simultaneously, but there is no the translation task there. So it was trained like predicting the next sentences, trying to discover mass words with different tasks and with a lot of languages at the same time. So what you have here is a general model that works well in a lot of sequence-to-sequence tasks. But to be able to use it for machine translation, you need to do now transfer learning, not for domain adaptation, but for task adaptation. So you are going to continue the training with parallel sentences so that the system learns how to do machine translation now that it already knows how to generate sentences. This task performs very well for some cases. In this case, for machine translation, we have seen that it depends a lot on the language pair. And in the case of Yoruba-English, is not being especially good. So our domain adaptation and data augmentation techniques perform better than this pre-training approach. Finally, we want to see what happens with multilinguality. Can we profit from different languages to translate only for Yoruba-English? So I'm giving you here some pre-trained models because these models are mostly trained with more than 100 languages, so it's really very difficult to train them in-house. But hopefully we have this pretend system that big companies put at our disposal. So before this we have, at the end of the table, I've added here Opus MT. Opus MT is not multilingual always, it has multilingual system, but it also has bilingual systems. So in this case, the developers just join all the data that they have for Yoruba-English and train a translation system from Yoruba into English with all the data they have. So that includes noisy and clean data, not only religious domains, several approaches. So if we use this pre-trained system, the Bleu score is around 6. And remember that we were getting close to 18. Then we have the true multilingual systems. I'm showing here Facebook M2M system and Google multilingual neural system. And they have differences and similarities. The similarity is that both of them are trained with 100 languages. So that's really multilingual. And the main differences is the data that they use for training. Google also mainly use data that it's translated from or into English. So these 100 pairs are a language into English or from English. Facebook, on the other hand, use a lot of pairs that include English, but is trying to work a bit more on language families. So it's, if I want to translate Spanish, for instance, into Portuguese, maybe it's good that I have some language directions that include languages like Spanish, Catalan, French, Italian, and not necessarily going to pivot through English. So they use English as main languages, but also lots of languages that are pivoting through Spanish or Chinese or Arabic, for instance. So in this sense, translation training is quite different. And we can see this in the performance. For the performance from English into Yoruba, both systems perform quite bad. The Bleu score is less than 4 in most cases, that it's quite worse than our baseline with Bleu score of 8. And the reason here is that this system uses all the data, noisy data and non-noisy data. And for Yoruba, this has a huge effect because Yoruba is a language that it uses a lot of diacritics. So when the language is noisy, this might mean that it's ignoring diacritics, that the corpus is not clear enough. And that makes that when you generate translations into Yoruba, diacritics are ignored, 90% at least ignored. And that has a very big impact into translation quality when we measure with Bleu, because Bleu is at the end measuring overlap with an n-grams. If your n-gram has a diacritic in one place and it's not in the other place, then the translation is completely incorrect, even if the word without the diacritic would be okay. So this is the reason why multilinguality here is giving so bad results. Then we go into English. Into the English, the situation is different. We have Facebook, that is a system that is using all language pairs and taking into account similarities into languages. And translation quality using this is quite bad, it's less than 5 Bleu scores. But then we have Google. Google is taking advantage of English. So they have 100 languages, all of them going into English. So that's a huge amount of data that involves English alone. And that makes generation of English in general very good. So you see that this is the best approach at the end, because you are getting a Bleu score of 22, that this is starting to be an understandable text with quite a significant quality. Not great quality, but quite nice to read already. So a summary of this, there are really lots of translation techniques that can be used for in the low resource setting. You can do different things. They are not going to perform equally well in different settings. So here, for instance, the diacritics in Yoruba are a key in order to understand which is the technology that you need to get. And let me, what time is it? Okay, we are getting close to the end. So yeah, let me do this short digression, and we will come back on all this at the end of our sessions in September. So let me just say a few words about these huge pre-trained models, that they are really huge. And they are great for some tasks. They can help a lot in your translations or in your NLP task. I haven't talked about BERT here a lot at all, but I'm sure, and you already told me before, that you know about BERT. But I have talked about this Google multilingual system, this Facebook multilingual system. What they have in common is that they really use lots of parameters. So if we think that BERT is big and it's difficult to be trained in our in-house GPUs, it has like 340 million parameters. But then we have to examine Roberta, we have GPT-2, you have GPT-3, that it was great some time ago with 175,000 million parameters. Then it came Google with 1.6 million parameters. That's an impressive amount of parameters. And I just read that China just developed a new pre-trained model that it was even larger than that. So this is really a huge amount of number of parameters. We cannot train these models by ourselves. And a question arises here. So it is useful for us to have these huge models. It's an interesting thing to have for our low resource setting. So I hope that after this course, we see if they are really important, and when and to what extent we need to use this. Just a related thought of this. I was in a presentation not a lot of time ago by Rada Mihalsia. She was talking about word embeddings. And at some point she put this slide. This is a print screen of her slide when she was talking about the energy cost that these kind of models have in energy, I mean, in terms of energy. So we see that for training, here on the right, we see that for training a transformer weak architecture, doing some hyperparameter sets and trying to do the best as you can, you would be using like this 626,000 emission of CO2. And this is much more than the energy, the emissions in CO2 that you will deliver if you have a car during all your lifetime. So this is 6 times more. So this is really a lot of energy that you are spending. And training a transformer big, if we go to the previous slide, is this transformer big could be BERT, okay? So this is 340 million parameters. Imagine the energy that you are expending when you need to train this Google huge language model. I haven't found the numbers for the previously, the recent models that we use. These statistics are for models that were there in 2019, beginning in 2020 when this paper came. So yeah, and in terms of money, this means that if you want to estimate your birth model by yourself, for instance, you would spend like $5,000 or even $10,000, depending on the kind of GPU that you are wanting to use. So this is not only a problem for low resource setting, this is now a problem for low resource scientifics and low resource community. Can we really afford to do things like this for training our system? And finally, let me finish today with this. I hope I have already convinced you that low resource natural language processing is a hard problem. Probably you're attending these seminars because you already agree on that and you know that there's a problem and you came here to find a solution. But this is a hard problem, especially because we are doing a lot of NLP with database approaches, deep learning approaches, and if you have no data, then you cannot apply your approach. That's quite clear. In this introduction doesn't expect it to be exhaustive or very wide. I've just given you some keywords and some initial ideas, and I will try to go deeper in the next days and try to understand some of them at least. But yeah, this is a spoiler. I'm not going to give you an universal solution about this because there are really lots of solutions, and I have shown you in the previous example, each solution can be different for a different problem. So not all low resource task is going to be approached in a similar way. So what to do next? So today I wanted to talk to you also about word embeddings, but the thing is that the slides that I prepared were really very basic, and with the answer that you have given to me at the beginning of the session, I saw that it was really too basic for you. So I just spent quite a lot of time doing the first part of the talk, so I hope we can have still some minutes for questions. And I will start next session talking about the embeddings in a bit more advanced way so that you don't get bored during half an hour. I will try to make it a bit more up level. And if, as I said before, if you are already working on low resource settings, you are very welcome to participate in the multilingual low resource translation task for Indo-European languages that we are doing at WMT. And we are also organizing a workshop on multimodal machine translation for low resource languages that will take place at RUNELP also this year. So if you have some interesting experiment to share with us, you can just present it there and we will talk at the end of this session. Okay, and now what I will do is go really fast on all the slides that I would like to have told to you. And just go to the slide where I ask for questions. So there will be more content next time talking about word embeddings. And now maybe we can use this like 5-10 minutes that we have to questions. And if not, I will select some of the things that I'm missing and I can fill the 10 minutes if you don't have any specific questions. So yeah, as you prefer. And let me stop sharing the screen so that I can see your faces. Okay, I'm seeing some questions in the chat. Please feel free to unmute yourself and just ask the questions. I think you have the permissions to unmute, right? Okay, if not, in the meantime, yeah, let me read the questions, which is why we should reuse models rather than train our own model from scratch. Maybe you can go through the multilingual embedding stuff only. So yeah, let me go to the first question, why we should reuse models.
I'm the one who asked that.
Okay, good,
Hello.
perfect. Hi.
Hello. No. So the first comment was just about the energy usage of training these models. And so, in order to be energy efficient, we should reuse pre-trained models rather than train our own from scratch. So maybe there should be a global effort to just train one big model, and then everyone uses it rather
Yeah,
than avoid them completely.
yeah. The thing is also, for instance, with this Facebook big multilingual model was put public to the community, the first version that they gave, we couldn't run it because yeah, they needed a lot of time to train it, lots of parameters. It was huge, but it was huge also to be running our own GPUs. So sometimes these models are great. They spend really a lot of time and a lot of money with them, but only big companies or big institutions can really make use of them. In this specific case, after some weeks, Facebook released smaller models, and we can use these smaller models. But the big ones, it's not really to be used by everyone.
And you can distill smaller models from the large ones as well, right?
Yes,
Once you've
well,
trained the large ones.
exactly. But they should do this because probably you don't have the capabilities to. I'm talking
Yes, yes,
about
yes.
GPT-3s or things or this huge Google language modeling. Sometimes you really don't have the resources to do even the distillation.
Mhm.
So I'm not against these models. They are, I mean, using BERT or some of these pre-trained models is really great, and it's really helping a lot. But yeah, this question is just, and I don't have a clear answer, of course. This question is just to arise some thoughts on which is the path that we really go to follow. So is this the way to approach low resource settings or low resource languages? Maybe we can think of another way. Maybe it's a combination of both, as always. So it's just an open question from my side.
Mhm. And the second thing I said was, even though we maybe all of us know about embeddings in general, maybe you can still go through the multilingual part of the embeddings. Maybe that's less known.
Yeah, I will probably do that. The first is that I have like 20 slides that were only showing you how to locate what's word to back and how it works. And yeah, maybe I can skip this part and go
I saw
directly.
some slides towards the end that seemed a bit interesting. That's why I said this.
Okay, yeah. So yeah, I will skip the most just introductory part, word to back and globe, and go to the multilingual and projections and this kind of things. Sure,
Okay,
I
thank you.
can do that. And then there is another comment here, maybe circulate a reading list to get up to speed on this. What do you mean exactly? So some suggested papers or something that I can also do is, well, circulate the slides with the papers I based the talks to, and I can do this either before the seminars, well, not a lot of before because yeah, I always finish the day before with the last points. But yeah, I can circulate the reference that I'm talking to, I'm talking about, and also my slides. So this is useful for the webinars, no problem at all. Any more comment or question? Okay, if not, what I will do is, yes, I see one comment from Joseph. No,
Focus,
sorry.
I was just clapping hands. Thank
Sorry,
you.
I thought
Thanks
it
for
was
the
the raised
presentation.
hand for a question.
Thank you very much.
Okay, so if not, what I will do is just write my email here in the chat. And if you have any suggestion or anything that you would like me to address, I mean, not change the topic because yeah, I know about this, I cannot explain you very different things. So just give me your feedback by email and we can make this useful for all of us. So this is the email and yeah, thank you all for attending. Yeah.
Thank you.
Thank you.